Good evening, everyone. Welcome back, and thank you so much for taking out the time to attend this session. For this last session on use of AWS AI services to extract information from documents, please join your hands in welcoming me, Ben Snively, who is the Senior Principal Solution Architect at AWS, to this stage. Over to you, Ben.
Thank you. Thank you. So thank you for joining. My name is Ben Snively. I'm a Senior Principal Solutions Architect in Data Science. And in my role, I work globally around the world, helping customers build solutions using machine learning and AI. In this session, we're going to be talking about how to unlock the data and insights out of documents. If you're like me, I'm constantly reading documents throughout the organization. There's lots and lots of rich information in those documents. So how can you build a system that's very robust and it pulls that information out so you could use it within your business processes, automation, compliance, and your various use cases? The way we structured this is first we're going to talk about what document processing is, what some of the old challenges are before you started using machine learning to do this sort of use cases, and some of the other additional challenges and reference architectures there. We're going to really dive into a very interesting use case that Lawrence Livermore National Labs did, where they had a mandate to very quickly do vaccination verification for COVID-19, and they had to do this for thousands and thousands of employees. So that would be really hard to do manually. So they had to automate very quickly, and they built a system in 4 weeks to be able to do this, and it was very successful. So we're going to talk about what they did, how they did it, and hopefully some lessons learned throughout that process. And then we'll talk about some key takeaways, and my favorite part is a demonstration. We're going to show a real system, taking insurance claims information, processing multiple documents, categorizing them, and pulling that information out to be able to really drive insights and process the claims. So within public sector, virtually every industry, every agency has documents. I haven't met a customer yet that doesn't have a document that has useful information in it. You know, when you look at education, tax information, healthcare, emergency response, all of these areas have these documents that really have a lot of useful information in it. So how can organizations take that and pull that out and build these things? And the way we're going to frame this discussion is around scenarios. You know, you might want to use those documents for different purposes. For example, you may want to take tax information, come in various forms. You know, many times organizations might have 10 different forms for the same tax information, 100 different forms. So how can you take that information, pull all the relevant fields out of it, and build an automated workflow, still involving experts to make sure you're getting the quality that you want out of the system to be able to process it. You know, another scenario is, oftentimes, not too surprising, there's a lot of very useful information in these documents. So how can you build a search system? And traditional search systems are kind of inverted index searches where you have to match the term exactly, but newer machine learning and deep learning technologies allow you to really ask questions of your documents and use the documents to really answer. So instead of matching the document, it's actually using the document to answer questions. So that's another scenario we're going to be talking about later in the session. And last but not least, how to use those documents to be able to build a compliance system. For example, Livermore National Labs, they had to be compliant with some federal mandates, and they built that system to be able to verify that vaccination information. So why is this hard? Why are we even talking about using machine learning and AI to do this? It really has to do with how dirty the data is. Oftentimes these documents, especially if they're scanned documents, they're images, there's handwriting, it's really hard to programmatically parse that information. So that's a really prime example of where you'd want to use machine learning because it handles that ambiguity. It's able to handle that uncertainty and then use that uncertainty to know when you want to involve your workers. Because if it's a very low confidence, you probably want somebody to look at it. If it's very high, let the process flow and let the workers really focus on the uncertain documents. But old ways, the legacy ways, also tend to do optical character recognition. And what that really means in layman terms is it's looking at the document and parsing characters. So what that means is you have to do a lot more work, right? Because now I have to form words. If there's a table in the document, I have to understand where the fields are, where's the header of the columns, what does this word mean in context of the domain of the document. So there's still a lot of work in kind of those legacy OCR techniques, and we'll talk about how some newer techniques really allow you to pull out higher level constructs. For example, pull out an entire table so that you could look at the rows, understand the column headers, and really kind of reason or understand what information is in the document. And really, it becomes very expensive using legacy techniques. If you think about, it's fine if you have to process 10 documents, 100 documents, but if you had to do thousands of documents, that would be a lot of overhead if a worker had to look at each and every one of those documents. So how can we help? What are some newer techniques to be able to take care of this? Really, this is where Amazon AI services come in. And what Amazon AI service is, and I'm not going to talk about the entire stack. There's a very large portfolio of kind of AI and machine learning services that you have at your disposal. But the power of AI services is there's already pre-trained models. And these pre-trained models know how to process forms. They know how to parse key value pairs. It knows how to parse tables. If you have an invoice, it knows how to read line items. So it's already been trained to be able to process certain types of documents. And that's powerful to you because you don't have to do that work. You can focus on getting that data back and reasoning it or processing it so that you could really use the data rather than spend a lot of time parsing the data, if that makes sense. The other thing is, oftentimes you want to enrich the data. So let's say it's an insurance claims information and there's a doctor's notes. After that information is pulled out, you might have a small semi-structured paragraph that has a diagnosis from the doctor. That's where you could really leverage additional AI services and techniques to really enrich the data even more. For example, you could take that medical information and match it to medical taxonomies. In fact, in the demonstration, we're going to show exactly how to do that. So this is really where folks are able to streamline the power of these AI services, but still not necessarily have to have a data science expert on every single team. One thing I should mention, we're going to go into a lot more detail about this in a moment, is even though it's an AI service and there's pre-trained models under the covers, you also have the flexibility to customize it, because anytime you pre-train something, it does a really good job most of the time, but there's always edge cases. And that's where that's where customers tend to customize the models. And through these AI services, and we'll talk about how to do this, you could customize it with your own entities. For example, if you're pulling out entity extraction, name entity recognition is the official term for it, you could define your own entities. For example, if it's a tax form, you may want to identify a tax ID and various other entities that you want to really treat as a type so that you could then process it. So how does this generally work? So the way we're going to be talking about this is what's the kind of overall architecture, the reference architecture that we see a lot of customers using in this, and then we'll actually fill in each of these blocks. So we're going to dive into more detail than this, but I wanted to start at a high level to set that context, so we didn't get lose the forest, not be able to see the forest and just focus on the trees there. So, but ideally, or usually, what happens is these documents tend to be somewhere. It might be in a document repository. It might be in S3. It might be streaming in through streaming services. So these documents tend to be coming in, and oftentimes there might be a very heterogeneous set of documents, meaning you might have license information, insurance claims information, invoices, all coming at you at the same time. So what do you have to do? First, it's good to understand what type of document you're working with. So a very common first step is to categorize the type of document. That way you could then fork off different business processes depending on what you have to do. For example, if I need to verify a license, I want specific fields, and certain fields have to be there, which is different than if I'm parsing an invoice. So a very common first step is to categorize what type of document you're working with, and that way you could then reason and fork off the different processes from there. Additionally, you might need to be able to have to convert that document from a scanned image. I was checking into my flight. I had to take pictures of my passport, my vaccination card, all these different images. So a very common initial step in addition to that is being able to take that image, it's really a whole bunch of bits in an image, and equate that to those higher level constructs I was talking about earlier. Here's the table, here's the invoice line items, those different elements. From there, oftentimes, we want to pull those key insights, those medical terms, those entities. You might want to be able to parse different images or logos within there. If there's actually a stamp, sometimes there's a inspector stamp. You could recognize who the inspector was. An interesting use case I was working with one customer is they want to understand every inspector, because if the inspector didn't have the right certifications, they wanted to pull all of those records back so they could recertify them. So various use cases where you want to enrich the data on top of the basic ingestion. And the last kind of key component that is worth mentioning is that verification. And this is really where humans are always involved with this. It's really that the shift here is rather than the human looking at every document, the worker is looking at the edge cases, those low confidence cases, and that's that last phase oftentimes when that happens. So let's step through each of these and talk a little bit more about how these services work, how you might implement your solution using these services in this approach. So at first, that categorization and being able to take scan images, maybe from National Archives, or there's many cases where it's just the image of a document rather than the document itself. And that's where customers tend to use a service such as Amazon Textract. And we'll talk a little bit more about how Textract works. But what that allows you to do is instead of processing those characters like a traditional OCR, it allows you to then tell it what you want out of the data. So I want all the tables out of this document. I want all the text. And the nice thing about this is when you pull the text out, it's not just pulling the characters. It's pulling, here's the words, here are the sentences, here are the pages that the sentences show up on. So you get that fuller context of the actual narrative that's happening in that document. Also, using AI services, I talked a little bit earlier about that kind of wide range of document types that might be flowing in. Amazon Comprehend Classification allows you to create categories of data sets. And during the demonstration, we'll show how you have a corpus of documents coming in, and we're identifying things like insurance cards, licenses, invoices, doctor notes. And that's done all automatically through the data flow, so that that simplifies the way the data gets pulled in, and it doesn't rely on external systems to tell you, oh, this is the license, because sometimes it will tell you the wrong thing, and you want to actually verify that as well. So at the end of this phase, there tends to be a set of categorized documents that you could then set up rules saying how you want to process that. From there, this is really where the enrichment happens, or the additional information gets pulled out of it. So we talked a lot already about the forms, tables, IDs, expenses that can be pulled out of that element. In addition to that, the peoples, places, all those custom entities are able to be routed through that mechanism. So let's talk a little bit about, and I'll go back to this screen, so we'll show the full architecture here in a minute, but let's talk a little bit about how these services work under the covers. I promise I won't go to 400 level, even though I really want to, but I want to give a little bit more context so you get kind of appreciation of what's happening under the covers. So with Textract, as I mentioned, rather than just characters coming out, you have the flexibility to tell the service what you want out of the data set. And that's where the categorization comes in. If it's an invoice, I might ask for different things than if it's a license. So within the service, through a single API call, and a lot of times it's really fun to show the code on this, because it's literally like 3 lines of code to be able to call the service and get this information out. And people are like, wow, that's really, really cool. If I tried to do that myself, it would take me weeks and weeks to code, and I wouldn't hit every edge case and stuff like that. So it's able to pull that text information out in that form. There's tables, the form information. I'll say one of the hardest parts out of any of these solutions, quite frankly, is handwritten text, because handwritten text tends to be super, super messy. And that's really where we see the most cases where you have that human workflow and you fork off that confidence level. And these kind of APIs that you see listed right now on the tech extract are really for use cases where you have a document that you want to process, and you really want to pull all the data out of that document. You want all the fields, all the knowledge in that document pulled out. But you might have another scenario. Let's say you're looking for a very specific field. So let's say you're processing, I'll talk about vaccination records again, just because it's very fresh in my mind. Let's say you only want the data, the first dosage, and that's the only field you want out of these vaccination forms, versus like all the fields of the date of birth, first name, last name. Usually it'd be the latter, but just as an example, let's talk about that. That's where there's a different API that you could use within TextRack called TextRack Queries. And what this does is, rather than getting the result and parsing a JSON that has this embedded in it, you actually ask the service the question, give me the first dose date. And what the service does is it processes that question and then uses that when it's actually analyzing the document to return the results. So in this example, you'll see it's actually asking, what's the year-to-date regular earnings? And the nice thing about this part of the service is you don't have to create a whole bunch of custom models. You don't have to create a whole bunch of synonyms. It's already baked into that, and it's matching it the best it can with the appropriate confidence level to be able to answer that question. So just to kind of reiterate, because I think it's an important point of when you'd use one approach versus another, you'd really use this approach when you want to pull some very specific questions out of the document. If you really want to at ingest time, if you really want to pull all the information out and store it into like a query database, you'd actually take that first approach. So if I was in your shoes, thinking about when I'd use one versus the other, that's kind of the thought process, if that makes sense. So that was being able to really process the document and pull out the information. But then how do we reason on it? How do we get entities, key value pairs, and other elements out of it? And that's where we have another AI service called Amazon Comprehend. How many folks in the room are familiar with things like name entity resolution? Okay, a handful of folks. So a very common approach to be able to pull back entities, which might be, an entity is really a field name that has an associated type. So a person's an entity, organization, a place, a date. So you actually get what the value is with the associated type. And this really is powerful when you want to be able to build things like knowledge maps and other scenarios where you need that type information to be able to understand not just the syntactical characters of what that field was, but what's really the meaning behind it, if that makes sense. You can do things like sentiment analysis, and we see this a lot of times with things like chat messages. If you're working with an organization that has like call centers that might be asynchronous chat and other flows where you really want to understand. Social media is another case where you do a lot of sentiment analysis of how's my agency doing for its constituents. You can do sentiment analysis in order to understand how people are talking about your organization, your agencies, your products, maybe your education software, that sort of thing. Key phrases are a little bit different than entities. So with key phrases, it's really looking syntactically at the sentence and pulling out phrases such as, I'm about to fly, so I'll give it an airline example. Ben really wants to upgrade his ticket to first class. First class is a key phrase. It's not, there's no built-in type called a seat. You could build that technically, but automatically that would be a key phrase because it's a key part of that sentence under the covers. Another, I won't go through each of these because, in the interest of time, but one other area that really resonates with a lot of customers I work with is identifying sensitive information. So a lot of times you'll have documents that have people's names, date of birth, and other sensitive information that you may want to redact. You want to strip out of a document so you can share it with others. So it allows you to be able to process the document, understand where PII, personally identified information is, so that then you could use that information and redact that. And in fact, during the demonstration, we'll show a small snippet of how that kind of works under the covers. As I mentioned, a lot of times these services built in handle many, many use cases, but there are edge cases where you need to customize the model. So within Comprehend, there's really two core elements that you could customize. You could build custom categories. Custom classification is the official term for it. And you'll see a demo of that when we're processing the insurance claims information. So we upload a whole bunch of documents, and we actually call the custom model to say, this is an insurance ID, this is an invoice, this is a license. And that was done through a very kind of small training data set. We built the model using a very AI service, so we didn't really need data science skills. We didn't define an objective function and gradient descent and do all that work. We gave it test data, training data, and had it build a model, and the service told us how well it did that. So we kind of get that feedback loop of how well did that model kind of get trained before we start using it. The other kind of key element, and you see some examples here in the bottom right, is defining your own entities. And I see customers do this a lot because in a business, you kind of have logical entities already, and those entities are embedded in this information. So being able to train your own entity types in addition to the built-in ones so that you could then pull those out and be able to populate your databases and other downstream systems. So that's a little bit about how those services work. We have tons of deep dive material on each of those, so I just want to give a glimpse of that. So let's talk a little bit back to that workflow again. So when we look at that workflow, we've taken those documents, we've ingested them, we've categorized them so we know the different types of documents. So we've reasoned a little bit on them to pull out the different entity types. So now it's time for post-processing. Let's do something with them. And this is really where there's no like one size fits all. Some folks put these in a Elasticsearch or an OpenSearch to be able to query it. Others will actually fork off business processes. Others will put them into a NoSQL database. And the decision of when to use one versus the other is really working backwards from what you're trying to solve. If I'm trying to build a search, I'll probably put in a search tool. If I'm trying to do compliance verification, it's going to kick off a workflow. So let the solution that you're trying to solve really drive your decision criteria of which approach to use to be able to send that data to, if that makes sense. But no AI system is perfect. If it is, I question if it's overfit. No machine learning model is perfect. So there tends to always be a human involved, especially as I was mentioning with things like handwritten texts. So this is where your workers, your kind of staff get kind of focused attention. And through the workflow, we have a service called Amazon A2I. And what this service does is it really allows you to have human-in-the-loop elements through this pipeline, through this workflow. So the nice thing about this is you could have thousands of documents, millions of documents. For example, I've worked with FINRA in the US, which is a financial regulatory authority, and they bring in millions of brokerage unstructured documents in every day. And what they do is they automatically process a lot of them, build a knowledge map of who the brokers are, what stocks were exchanged, what organization are they associated with, so they can identify fraud. But if we tell them using our services we're not confident on a specific data element, they fork off and have people look at it. So it's really a great mechanism to build a high-quality data set so people are looking at the right elements. The nice thing about A2I, it stands for Amazon Augmented AI, is that there's many, many built-in workflows. I can't recall the exact number. 60 pre-built workflows. So there's many, many workflows that do common tasks in the public sector space. So most of the time when I'm working with customers, at first they're a little hesitant. How do I bring this human into like an automated flow? But as they look at these built-in workflows, they tend to resonate and are able to broaden. So my favorite part, let's talk a little bit about a real example, or I'll call this a example we put together to show at the summit that illustrates a very common approach we do with customers. So this is going to be an example of being able to process insurance claims information. And rather than kind of going through the flow and then showing it again, I just wanted to skip straight to the demonstration. So essentially in this demonstration, what we have is we have this portal. This is kind of a scenario portal. We have it actually in open source, so you could actually go on GitHub and see a lot of this code and see how it works. But what we have here is we have various insurance claims, and you'll notice some of them have already been approved automatically or rejected automatically. And that's done through the confidence intervals that we set that you could define as your organization. But now what we have is we have this big corpus of documents on a new claim that we want to process. And here you see things like a big form with key value pairs, tables. We have things like licenses that are uploaded into the system here. This obviously is a fake license under the covers. There's invoices. So we have this big corpus of information that we want to process. So what's our first step, right? We want to be able to handle these data types differently, so we need to understand what type of document it is. So what you can see here are the various document classifications, and this was derived automatically through that custom model that we built. And it was done very, very quickly, very easy to build that custom model. And you'll notice highlighting on the text there, that low confidence interval one said 57% confident. So that was one that we needed to review to be able to look at. Here you could actually see all the different types that we define in the system. This is a setting you could define, so you don't have to use those types. You could define it within your organization under the covers. So here, now we're going through the enrichment phase, or really the insight phase. So here you can see calling that TextTrack service. What it did is it didn't give us characters. It gave us key value pairs. It gave us the table itself in a table form for us to be able to process under the covers. When we look at the insurance card, again, it gives us the group number. It gives us these kind of higher level constructs that we could use under the covers to be able to process and really kind of very, very quickly build an automated flow or automated system under the covers. This one is really interesting because now we have an invoice. This is a new type. Now we have line items that have prices and elements under the covers to it. So when we, again, you always get the key value pairs, but when we go to the line item fields, you'll notice now we have a different construct. We have line items, so now we can see what was on the invoice, what the price was. We could sum those up, apply business rules on top of that under the covers. Here's an example of the named entity recognition with the custom types of patient name, admitted date, the patient ID. So these are custom types that have been defined in the system. And here's some examples of kind of systemic types. These are pre-built types that everyone knows what a date is. So those are actually built into the system. And in this other example here, we're mapping it to medical taxonomies. So this is a built-in feature of Comprehend Medical, so that you could get the ICD-10 codes for the different diagnoses. The really kind of powerful thing here is you also get relationships. So if there's a drug that was prescribed, you get the dosage, you get the kind of the diagnosis, you get kind of the relationship information under the covers as well. And then here's an example of redacting the PII. Here's the provider note. It gives you the index of where that PII data was, so you could then mask it under the covers. And at the end of the day, very, very quickly, we could take all this information in, look at the very low confident fields that could show up in the various documents, and then ultimately send it to the claims decision system, or it could be a compliance system like Livermore National Labs has, and that sort of flow. So, I know that was super quick. I could probably spend an entire day just talking about insurance claims processing, but I wanted to give a little bit more breadth of other scenarios of document processing to kind of show a little bit of the art of the possible in different areas. So next, we're going to talk about the Livermore National Labs use case. So Livermore National Labs essentially is a federal funded lab in the US that does cutting edge research in science and technology. They were created by University of California, Berkeley, I think in the 1950s. Don't quote me on the exact year. They've been around for a very long time, and very cutting edge research happening within the laboratory. In fact, this is a picture of the laboratory. It's quite an impressive campus that they have. And what they had is they had that federal mandate where they had thousands of employees that had to go back to work. And the reason why they went back to work is they have some very powerful on-premises HPC computers. This is El Capitan. It's actually one of the top HPC computers in the nation. It competes in the national rankings. And what's really interesting is this is a very powerful resource that they've built, but it's very limited. So they actually burst HPC into the cloud as well There's some really good sessions about that. Unfortunately, I can't talk about that today either. But if you're in the HPC space and you want to learn a little bit more about that, some really good content out there on there. But what they really had to do is there's this federal mandate where any employer with more than 100 employees had to do vaccination verification. And the interesting thing about this is, visiting here, it's really nice there's a federal system to be able to identify vaccination. They don't have that luxury. They have all these different organizations doing vaccination forms. There's the CDC, there's Kaiser Permanente, there's the state of California. So they had all these different forms, and you could actually see them on the right-hand side here that are coming in to be able to do that vaccination verification. So what they did is they actually built this system. They built the system from idea to production in 4 weeks, no exaggeration. So within 4 weeks, they were able to build the system. I think we had it with them testing within a week. So really that speed to innovation, that speed to delivery is very powerful. If they were building their own machine learning models, I think it would take them a week to build a model, right? You don't build a model in an hour that's high quality. And that's really where a lot of the power of these pre-built models and these AI services come into play. Really, another good architecture. You'll notice microservices. So in the top, you'll see a microservice to be able to identify the vaccination type. This is where it identifies if it's a CDC vaccination record, if it's Kaiser Permanente, if it's the state of California. They happen to be, in their case, they happen to be using SharePoint to be able to store all this information. So they had their SharePoint call into the microservice to be able to understand how this process flow, to really kick off this process flow. And then from there, they have another microservice to be able to pull back in a JSON form, very consumable, all the vaccination information. So who the employee is, what the date of birth is, when was the first dosage, when was the second dosage, was there a booster delivered? So all this information comes back to them to be able to process that. And at the end of the day, they were very, very happy. I'll talk about some of their successes in a moment. But I want to show you a little bit about some real data and why this could be a challenge if machine learning is not used. So if you take a look at some of these records, it's very inconsistent. Sometimes there's smudges. Sometimes the orientation of the document is different. Sometimes it's handwritten. Sometimes there's a stamp. There's so many different variations. I could never imagine trying to code this with if-else, if-then else's and stuff like that. It would be like a nightmare. I think I would quit. I love software engineer, but I think I'd quit software engineer for at least a month if I had to do that myself. And that's really where a lot of the power of these machine learning algorithms come in. Here's an example of processing the CDC form, and over on the right-hand side, just like the insurance claims, you'll see first name, last name, the patient records, the date of birth, all the different fields that come in. And if you're thinking about doing this yourself, the nice thing about this is you could also log into the console, and if you have a sample document, you could actually upload it and just see how it performs. So it's a very easy thing to look at, see how it performs, and kind of iterate on before you do a big investment to be able to build an entire workflow. So why am I talking about Livermore National Labs? These are numbers from them, so this isn't a quote. This table's not for me, so this is something that they provided us. They had 78,000 employee vaccinations they had to process. And of those, 6,000 of them had a very high confidence score where they didn't even have to look at them. So, if this was 100, they probably would have just looked at them themselves, right? Why develop a software system if you had to do it once and you never did it again? But they had to do this, and they had multiple contractors go in and have to do this over and over again. The other really impressive thing is if you look at how much it costs to do this using the AI services, it was about $1,400 US to be able to build this system, and they did it in 4 weeks. And their quote was the number of hours they saved by using these AI services was a lot of time. So, just wanted to kind of give that as an example. If you're thinking about when to use the AI services, if you're trying to solve the problem and there's an AI service that matches your use case, I'll definitely take a look at it to see if it's going to fit into my solution. So that was a little bit on the compliance and control element, and I'll try to save a little bit of time for questions here, but I wanted to give a few other architectural patterns that relate to search and discovery. So search and discovery is a little different than that other use case. In the other use case, we wanted to take a whole bunch of information and identify who could come back to work and who can't for compliance. So it's really generating these lists and flagging different employees. What if you need to find content and find information out of the system? In this architecture, and we have there's links at the bottom, and these will be posted later on. Again, it's using things like TextTrack and Comprehend, but instead of using that and really processing that workflow, we're sending that data into an inverted index. And there's different approaches. Inverted indexes are great when you want to be able to pull information out. If I wanted to be able to ask questions of all the documents, for example, we helped Imperial College in the UK built a system called PanSearch during COVID-19 that processed thousands and thousands of COVID-19 research papers. And you could do things like, what's the R0 value of COVID-19, which is really a value of how quickly COVID-19 spreads. And what the service did using things like Kendra is you're able to ask that question, and instead of matching that exact question, it looks in the documents and searches for where it's going to answer that. So it's a little bit different use case of search, where if you want to be able to create give me all the documents that have these terms, you'd want to use something like OpenSearch or Elasticsearch. If you want to be able to reason on the document and be able to ask questions and get answers that are kind of embedded in the document, that's where you'd use services like cognitive search or intelligent search services like Amazon Kendra under the covers. One other last example I wanted to mention is how do you handle this at very, very large scale? And you'll notice some queuing mechanisms here. So queuing is great to be able to handle very spiky workloads and kind of massive load on systems. So in this example, rather than having S3 call Lambda, which is a very direct call, you're calling a function and it's starting to execute, oftentimes you want to be able to really throttle that, and you want to be able to buffer that to be able to protect downstream resources and other scenarios. So here you'll see Amazon SQS, which is the simple queue service, collecting kind of all the work. So the queue contains, here's the work that needs to be done, and that work gets kind of plucked off the queue to be able to process that information. And at the end of the day, you'll notice a lot of these patterns are very similar. It's just kind of deciding on your workflow what needs to happen. Do you need to verify that information, build a search tool, be able to process very massive information? In this example, it's pulling into the DynamoDB under the covers. So, why have we been talking about this? What are some of the key takeaways under the covers? Really, how do you do this operationally at scale? Do more with less, and have the very precious resources of your teams focus on what matters. They don't have to look at every document, and everything is automated as much as possible. But you still have those folks be able to handle those edge cases, those kind of noisy data elements, which I have never seen a real data set. Sure, fake data sets are clean. I've never seen a real data set that doesn't have any noise at all. Complex documents can be daunting. It could look like it's very complex. What I'd say on that front is start small, pull the different relevant information on it, and then you could iterate and pull more and more information out. Maybe you want to pull all the tables, get all the narratives, pull the entities out, and start building incrementally on the system. And it really allows you to drive better customer experience under the covers. And with 2 minutes to spare, what are some next steps if you're interested in learning more? The first thing I'll mention is throughout kind of the deck, you'll notice there is some GitHub links that have a lot of examples. If you want to see how this works under the covers, if you want to get your hands dirty and stand this up, there's something called CloudFormation, which is infrastructure as code, where you can stand up these different elements and test it out. Definitely reach out to your kind of AWS teams, have them help you with these solutions. There's training, proof of concepts, lots of different routes to get started. One of my best recommendations is I've seen customers go into analysis process mode. Sometimes it's just better to try it learn from it. Maybe stop going one approach. Maybe store. I might store the data in OpenSearch at first and realize I need it in Kendra. But we call that as a two-way door, meaning you could try it, figure out if it's right, back out, and figure out the right approach. So, and one of the last slides here, how do you learn more? You've probably seen this slide throughout throughout the summit, so I'm not going to over-index on it, but lots of ways to build your skills, get hands-on, get certifications. The certification is great. There's actually a machine learning dedicated certification that you could go look at. There's lots of online training that is great to be able to prepare for that, and that's a good mechanism to be able to really understand what's happening under the covers and follow the best practices and stuff like that. So with a few seconds to spare, I will stick around for questions, so feel free to stick around if you have any questions. But I want to thank you first and foremost, and also almost as equally important, but not quite, please fill out your surveys. Every one of us look at those surveys. It's critical. You could be completely honest, so please fill out your survey, and I hope you enjoyed the session. Thank you.